Nobody expected anything unusual when the European Space Agency released a routine data dump from one of its Mars orbiters. Most of the time, these images show nothing more than dust storms, crater shadows, or the faint outlines of Mars's thin atmosphere. But buried in this batch was something that didn't fit. An object drifting just past a red planet, glowing with a strange intensity that didn't match any known comet. At first glance, it looked harmless, maybe even boring. Yet the more scientists studied it, the more the story twisted into something far stranger. This visitor wasn't from around here. It wasn't even from the outer solar system. It came from somewhere else entirely. An interstellar traveler that slipped into our neighborhood with a kind of timing and precision that felt almost intentional. Astronomers named it 3I Atlas, the third confirmed interstellar object in human history. But the name was the only ordinary thing about it. From the moment its trajectory was calculated, the numbers made seasoned researchers stop mid-sentence. Instead of barreling in at a random angle like every natural interstellar object before it, 3I Atlas slid into our planetary system almost perfectly aligned with the flat disk where Earth, Mars, and the other planets orbit the Sun. The odds of that happening by chance? Roughly the same as throwing a dart from a speeding car and hitting a bullseye 2 miles away. And somehow, this thing made the shot. But the alignment wasn't the part that sent shockwaves through the astronomy world. It was the behavior, the glow, the speed, the complete disregard for the rules every comet is supposed to follow. Each new image piled on another contradiction, and by the time the first serious analyses were complete, one conclusion became impossible to ignore. 3I Atlas wasn't acting like a comet, not even close. And the deeper scientists looked, the more the mystery sharpened into a question nobody was prepared to ask out loud. If it's not a comet, then what exactly is drifting toward our inner solar system? But the next discovery pushed that question into an entirely new realm, because the object wasn't just unusual.
To understand how this all began, we have to rewind to a cold, quiet night on July 1st, 2025, when the 3I Atlas Survey telescope in Chile was running one of its routine asteroid sweeps. This system scans the southern sky every night, looking for anything that might pose a threat to Earth. An unnoticed rock, a dark wanderer, something that slipped past older surveys. Most of the detections are false alarms. A few are real asteroids. Almost none are interesting. But that night, something strange flickered across the data stream. A bright dot, unusually bright. At first, the team assumed it was a typical near-Earth object, reflecting sunlight at the right angle. Nothing worth more than a quick classification. But when they plugged the coordinates into their trajectory models, the results didn't make sense. The projected path wasn't curving into an orbit around the sun. It wasn't looping back from the asteroid belt. It was coming from outside the solar system entirely. The realization spread through the astronomy center like a spark catching dry grass. Phones rang, email alerts popped up. The trajectory was recalculated again and again, each time with the same unmistakable result. This object had traveled across interstellar space to reach us. And that wasn't even the strangest part. Unlike previous interstellar visitors, small, dark, barely visible rocks drifting through like cosmic debris, this one was bright, too bright. Comets don't usually glow like that unless they're being pushed by sunlight, expelling gas and dust in massive icy plumes. But 3I Atlas wasn't showing the characteristics of traditional outgassing. In fact, it looked stable, almost controlled, as if something inside it were resisting the sun's heat instead of reacting to it. Then came the second anomaly, its path. Natural objects that enter the solar system from deep space fall in at random angles. They tumble, spin, and careen through gravitational fields like drifters caught in a storm. But 3I Atlas wasn't tumbling. It wasn't spinning chaotically. It was moving with a clean, almost eerily precise alignment along the ecliptic plane, the same thin flat disk where every planet in the solar system orbits. The probability of that happening naturally, astronomers estimated it at roughly 1 in 500, small enough to make even seasoned scientists pause. This was the moment when Avi Loeb, the head of Harvard's Galileo project, started paying attention. He'd spent years arguing that not every interstellar object would behave like a dusty snowball. Some, he suggested, might be more deliberate. And when he saw the early data on 3I Atlas, the brightness, the trajectory, the precision, his instincts lit up. But the true shock didn't arrive until weeks later when the Hubble Space Telescope locked onto the object and captured images that defied every principle of comet physics humanity had relied on for centuries. Because what Hubble found didn't just raise questions, it shattered expectations and forced scientists to reconsider the rules they thought.
When the Hubble Space Telescope finally turned its gaze toward 3I Atlas, nobody expected anything dramatic.
dramatic. Hubble had photographed dozens of comets before, capturing tails stretching millions of kilometers and icy nuclei shedding vapor into the void. Scientists assumed they'd get clearer images, confirm standard comet behavior, and move on. But the first process frames stopped the research teams cold. Something was wrong. Very wrong. Every comet ever observed in human history follows one fundamental rule. Its tail always points away from the sun. Solar radiation hits the comet, heats its surface, and blasts out gas and dust that the solar wind pushes outward like smoke carried by a relentless cosmic breeze. It's basic physics, so reliable that astronomers use tail direction to confirm a comet's position. But 3i Atlas refused to play by those rules. The Hubble images showed a faint extension coming off the object, but it wasn't pointing away from the sun. It was pointing toward it. A sunward jet, a completely backward phenomenon, a feature that on paper simply should not exist. The moment the images hit the internal databases, confusion erupted. Teams at NASA, ESA, and independent observatories around the world scrambled to verify the anomaly. They reprocessed the data. They checked calibration files. They ran simulations to see if a viewing angle illusion could explain the bizarre geometry. Nothing worked. The jet was real and it was aimed directly at the sun. This wasn't just a weird detail. It broke the foundational physics of how comets behave. Natural jets only form when ice sublimates away from solar heat. A jet firing toward the sun meant that some mechanism was pushing material in the opposite direction of natural forces. That's when Avi Loeb's attention shifted from curiosity to concern. As the lead of the Galileo project, which investigates potential extraterrestrial technology, he'd been tracking the object's odd trajectory. But this anti-tail changed everything. Loeb described it like this: a glow in front of the object, no dust plume behind it, and no evidence of gas molecules behaving the way they should. Nothing about it matched the chemical signatures expected from a normal comet. The scientific community, determined to avoid sensational conclusions, tried to explain it away. Maybe an asymmetric shape caused a misleading reflection. Maybe dust particles were arranged oddly. Maybe some new form of crystalline ice behaved strangely under solar radiation. But then the Keck 2 telescope in Hawaii, one of the most powerful optical instruments on Earth, aimed its massive mirror at 3i Atlas in early August. Its high-resolution observations confirmed the same The anti-tail alone was enough to rattle astronomers, but the real shock hit in late September when spectrographic instruments finally broke down the material streaming off 3i Atlas. These instruments work like cosmic DNA scanners, splitting light into its chemical fingerprints. For normal comets, those fingerprints look familiar: water ice, dust, carbon compounds, the usual frozen leftovers from the early solar system. But 3i Atlas didn't give the usual signatures. It gave something stranger. The first red flag came from a peculiar burst of nickel detected in the outgassing. At first, nobody blinked. Comets can contain metals. It happens. But when researchers dug deeper, they noticed something missing: iron. Nickel without iron is like finding salt without sodium. The two are born together in massive stellar furnaces. They condense together. They travel together. They stay bonded through billions of years of cosmic chaos. Yet, here was 3i Atlas, bleeding nickel with no accompanying iron. Natural processes simply don't separate those metals. It takes extreme, deliberate refinement, the kind used in advanced engineering on Earth to produce heat-resistant alloys for spacecraft skins and turbine blades. Suddenly, a quiet question began whispering through research labs and observatories. Why does this comet carry a signature we only see in industrial materials? But the anomalies weren't done. Using its powerful infrared sensors, the James Webb Space Telescope revealed something even more unbelievable: a carbon dioxide to water ratio of 8:1. To put that in perspective, most comets hover around 1:1, maybe 2:1 if they formed in unusually cold regions, but 8:1? That number sits so far outside the natural range, it might as well be from another universe. This suggested 3i Atlas formed in temperatures far colder than anything seen in our solar system's comet nurseries, an environment so frigid only the outermost regions of alien star systems could produce it. And even then, something didn't add up. A comet with this much CO2 should start venting long before it reaches the inner solar system. It should roar away far beyond Jupiter, its gases blasting into space under the faintest warmth of sunlight. But 3i Atlas stayed unusually quiet during its approach, almost as if something was holding the gas in, restraining the outgassing until it was deeper into the sun's heat. Avi Loeb posed a question most scientists refused to touch. What if the carbon dioxide wasn't just part of the object, but a coating, a shield, a protective layer designed to survive the brutal journey through interstellar space? Then came the cyanide detection. Again, not unusual by itself, but the pattern was wrong. The release didn't follow natural rotational rhythms. Instead, cyanide vented from both the sunward jet and the traditional tail simultaneously, as though multiple systems were operating together. Natural comets don't coordinate, they don't synchronize, they don't behave like machines. One observer described the dual direction venting as structured chaos, a pattern that felt engineered rather than random. And with every new discovery, one unsettling question kept gaining momentum. If these chemical fingerprints don't belong to a natural...
Up to this point, 3I Atlas already looked strange enough to spark debates across every corner of astronomy. But then researchers examined something even more fundamental, its motion. And that's where the story broke open. Because nothing about the object's flight path matched the behavior of a natural comet drifting through space. When 3I Atlas first entered the solar system, instruments clocked its speed at 58 kilometers per second. That's blisteringly fast, nearly twice the speed of the previous interstellar visitors humanity has observed. For most scientists, that alone was astonishing. Objects moving that fast usually barrel in on wild, unpredictable angles after wandering the galaxy for billions of years. But 3I Atlas wasn't barreling. It wasn't tumbling. It wasn't diving in from some random orientation. It was slicing through the solar system like a precision-guided arrow. Its orbital eccentricity, the number that tells you how stretched or extreme its path is, came in at 6.137. Anything above 1 is already hyperbolic, meaning the object will slingshot around the sun and never return. But 6.1 is so extreme, the trajectory looks almost perfectly, as if 3I Atlas were less like a comet and more like a projectile passing through our star system. Yet even at that impossible speed, it aligned within 5 degrees of the ecliptic plane, the same thin flat disk where every major planet travels. The odds of this happening by chance? Only a few percent, depending on the model you use. Not impossible, but certainly not comforting. Still, coincidences happen, until you look at the timing. On October 3rd, 2025, the object drifted close to Mars. Then in March 2026, it would sweep past Jupiter at just 54 million kilometers, a cosmic hair's breadth. And during its closest approach to the sun, it passed directly behind our star from Earth's perspective, completely hidden from view at the exact moment scientists most wanted to observe it. A coincidence? Convenient? Or something else? This pattern is what pushed Avi Loeb to raise a controversial possibility. He suggested 3I Atlas might attempt what's known as an Oberth maneuver, the technician. If an object wanted to alter its path while remaining unseen, there would be no better place than directly behind the sun, where Earth-based telescopes can't observe it. That's why Loeb called the situation a black swan scenario. He wasn't claiming certainty. He wasn't declaring the object artificial. Instead, he argued that the combination of alignment, timing, and behavior was unusual enough to deserve attention, not dismissal. The broader scientific community pushed back. Most astronomers labeled the idea speculation without evidence. They argued that 3I Atlas still behaved like an extreme but natural comet. But even skeptics noticed that multiple planetary defense groups quietly added the object to their watch lists, not because it posed a threat, officially, but because too many variables weren't lining up neatly. And if the trajectory does shift in unexpected ways, if the path changes after perihelion, if the object behaves as though it made a hidden maneuver, then everything we think we know about 3I Atlas... October 3rd, 2025 should have been a historic moment, the kind researchers dream about. As 3I Atlas swept within 29 million kilometers of Mars, multiple spacecraft were sitting in perfect positions to capture unprecedented data. Between ESA's Trace Gas Orbiter, Mars Express, NASA's MRO, and even China's Tianwen-1, we had a literal ring of robotic eyes circling the red planet. If there was ever a chance to unravel the mystery of this interstellar visitor, this was it. And the only public images ever released were blurry. Not the detailed images scientists hoped for, not the spectroscopic breakdowns, not the high-resolution scans the world expected. Instead, the public received only a few faint white dots. The sensors weren't optimized, the target was too faint, too distant, too fast. All technically true, but still odd. Especially when you consider that NASA's high-resolution imaging science experiment, HiRISE, had been imaging Mars for over a decade. And here's where the story tightens. NASA confirmed privately that HiRISE did capture images of the object. The data was transmitted, the processing was completed, but the results never appeared. Not delayed, not summarized, not teased, just absent. Officials cited timing and solar conjunction. They said the object was slipping behind the sun. They said it was better to wait for more stable post-perihelion data. All perfectly reasonable explanations. Still, the silence felt strangely heavy. Meanwhile, ESA released their own set of extremely low-resolution images, the same diffuse white dots seen against a star field. They served as confirmation of the trajectory, nothing more. But curiously, they didn't mention whether their spectrometers picked up the nickel anomaly again or anything at all. It wasn't until some researchers pointed out an uncomfortable reality that things got even stranger. This was the first interstellar object ever targeted by the International Asteroid Warning Network, and ground telescopes across
across the world were aligning. And yet officially, 3i Atlas poses zero danger to Earth. So why mobilize the same network used for planetary defense? Why monitor an object that, according to all public statements, isn't coming anywhere near us in a threatening way? The questions only got louder when some astronomers noticed that 3i Atlas's path didn't seem to react to solar pressure the way a typical comet should. Natural comets shift slightly as their jets fire. Their trajectories wobble. They twitch. But 3i Atlas glided past Mars with a stability that felt unnatural, almost controlled. Of course, most scientists dismissed this as speculation, but even the skeptics quietly admitted that something about the Mars flyby felt off, not because of what we saw, but because of what we didn't see. And now the world waits, because after slipping behind the sun, 3i Atlas is about to re-emerge into the morning sky, and whatever it does next will determine whether this entire mystery collapses into...
As October faded and 3i Atlas slipped behind the blazing wall of the sun, the world was left with nothing but unanswered questions. Telescopes fell silent. Instruments went blind. For weeks, nobody on Earth could see the object at all. The perfect blackout window right when its behavior mattered most. And that's why the next phase has scientists, amateurs, and sky watchers glued to their charts. Because starting around November 11, 2026, this is the moment everything hinges on. If 3i Atlas is a natural interstellar comet, just a rare, extreme example of what's drifting between the stars, then its behavior should calm down. The bizarre anti-tail should fade. The jet should swing back into a normal orientation. The chemical signature should settle into something predictable. It should dim, drift, and disappear into deep space, just like every other icy wanderer we've ever observed. But if the anomalies persist, if the sunward jet continues, if the gassing patterns stay unnatural, if the trajectory strays from the predicted path even slightly, then the questions surrounding 3i Atlas grow heavier, especially because December brings the next critical milestone. On December 19th, 1.88 AU, a distance close enough for powerful ground-based telescopes to finally resolve real details. Surface features, jet structures, thermal properties, the kind of images that could eliminate doubt or ignite a firestorm of entirely new speculation. Amateur astronomers worldwide are preparing for this moment. Thousands of independent telescopes across multiple continents will be pointed at the same place in the sky, forming an unofficial global network, not controlled by any government, not limited by any agency, and not filtered through institutional caution. For the first time, eyes outside the scientific establishment will get a chance to study the visitor themselves. But even that isn't the biggest event on the horizon, because the March 16th, 2026 flyby of Jupiter is what researchers are quietly calling the final exam. Jupiter's massive gravity can expose even the smallest deviations in an object's motion. If 3i Atlas behaves like a natural comet, the giant planet's pole will nudge it in entirely predictable ways. Every simulation says so. But if it doesn't, if the path shifts in a way no gravitational model can explain, if something about its motion suggests controlled maneuvering, then the debates that have simmered beneath the surface will explode into the mainstream overnight. NASA's Juno spacecraft may catch the best view of all. Its instruments can capture details down to just a few kilometers if everything lines up. And ESA's JUICE mission, though currently operating in a reduced mode, may also get a shot at observing the object from an angle no Earth-based telescope can match. What those spacecraft see or don't see will shape the entire narrative surrounding 3i Atlas. Even Avi Loeb, who assigns only a 30 to 40% chance of non-natural origins, admits the next few months will decide everything. If 3i Atlas transitions into ordinary comet behavior, the mystery dissolves. It becomes a fascinating but natural object, one that simply stretched our expectations. But if it doesn't, if the anomalies continue stacking up, if the coming observations reveal even one new contradiction, then 3i Atlas may become something far more than a comet, something that forces humanity to rethink its place in the universe. For now, all we can do is watch the sky and wait for the visitor.
As 3i Atlas, still the universe doesn't hand out definitive answers easily. When 3i Atlas brightens again in our skies, it might settle comfortably into the role of a natural comet. Bizarre, rare, extreme, but ultimately explainable. Or it might continue behaving in ways that stretch the definition of natural to its breaking point. Either outcome tells us something profound. If 3i Atlas turns out to be ordinary, then it means the universe is far stranger than we believe, filled with icy wanderers capable of mimicking the impossible. It would reshape our expectations of what interstellar debris can look like, and hint that countless other equally unusual objects may be drifting between the stars. But if the anomalies continue stacking up, if the behavior keeps defying the simplest physical rules, if the next round of observations only deepens the mystery, then we may be confronting something far more unsettling. that we are not the only engineers in the galaxy, and that some distant civilization, long vanished or still active, might have left behind machines, probes, or relics wandering space in absolute silence. 1. Are we alone out here, or have we simply been looking in the wrong places? As the object drifts back into view, telescopes around the world will turn toward it, waiting for answers. But in the end, the truth about 3I Atlas might not come from a single photograph or data point. It might come from what the object teaches us about our own curiosity, and the possibility that the universe still holds secrets far beyond anything we've imagined. Because whatever 3I Atlas truly is, one thing is certain: this won't be the last interstellar visit. Even as 3I Atlas recedes toward the depths of space, its visit leaves questions that will linger for decades, perhaps centuries. Every anomaly it has displayed forces us to reevaluate assumptions about physics, chemistry, and the limits of natural cosmic processes. Think about it. A single object can challenge centuries of accumulated knowledge, spark debates at the highest levels of science, and make even seasoned astronomers pause in disbelief. For most of human history, interstellar visitors were purely theoretical. Now, one has arrived in our backyard, daring us to look closer and question everything we thought we knew. The implications are profound. If objects like 3I Atlas are capable of behaving outside natural expectations, it means the universe may be filled with surprises, structures, phenomena, or even traces of intelligent design that we have simply never considered. And that raises another question: are we ready to recognize them when they appear? Even if 3I Atlas turns out to be entirely natural, its story teaches a critical lesson. The universe is stranger than we imagine, and curiosity is our greatest tool for survival. By watching carefully, questioning boldly, and keeping our minds open, we prepare ourselves not only for the next interstellar visitor, but for discoveries that could change our understanding of life itself. In the end, 3I Atlas isn't just a comet, or an object, or a scientific puzzle. It's a reminder, a wake-up call, a challenge to humanity, to explore, to observe, and to embrace the unknown. And one final thought, perhaps the most important: if an object can travel across the galaxy, surviving conditions billions of years old, reaching a star system far from where it was born, then maybe even as 3I Atlas drifts onward, disappearing into the vastness of space, its story is far from over. Every unusual trait, every anomaly, every unanswered question remains a challenge, not just to astronomers, but to all of humanity. What will the next interstellar visitor look like? Will it be another strange comet, a relic of ancient stars, or something entirely beyond our imagination? 3I Atlas has already stretched the limits of what we thought was possible, and it has reminded us that the universe is far more complex, subtle, and mysterious than any single model can explain. For those who study the skies, for those who dream of other worlds, the arrival of this object is a wake-up call. The cosmos isn't a silent void. It is active. It is unpredictable. And sometimes it delivers a visitor that forces us to question everything. Perhaps 3I Atlas will fade quietly, leaving only data and speculation behind. Or perhaps it will continue to surprise, revealing secrets hidden just out of reach. Either way, humanity now knows that the galaxy is not as empty or as quiet as we once believed. The question isn't just what 3I Atlas is, it's what it represents. A universe full of possibilities, mysteries, and challenges waiting for us to notice. And maybe, just maybe, the next object to arrive will demand that we pay even closer attention, because the story of interstellar visitors is only just beginning. So keep watching the skies, because the universe has a way of showing up when you least expect it. And even as 3I Atlas continues its journey out of our solar system, the bigger story may be what comes after. This interstellar visitor isn't just a one-off curiosity, it's a wake-up call. The universe is vast, ancient, and full of objects we have never imagined. For every 3I Atlas that passes through, countless others may have already visited undetected, silently reminding us of how small and new our understanding truly is. The anomalies we've observed, the sunward jet, the nickel-rich composition, the perfectly aligned orbit, might be a rare natural occurrence, or they might hint at something far more extraordinary. And that uncertainty is exactly why scientists, amateurs, and enthusiasts alike must continue watching. Every observation, every measurement, every unexpected detail could rewrite our understanding of the cosmos. Avi Loeb's work shows that embracing uncertainty is not sensationalism, it's science. And whether 3I Atlas proves to be natural or artificial, it has already forced humanity to confront the possibility that the galaxy is far stranger, far richer, and far more mysterious than we ever imagined. So the question isn't just, what is 3I Atlas? It's, what else is out there waiting for us to notice? And how ready are we to recognize it when it arrives? The
sky is no longer a backdrop. It's a story, one we are only beginning to read. 3i Atlas has already forced us to rethink everything we thought we knew about interstellar objects. From its impossible trajectory and sunward jet to its unusual chemical composition, this visitor has pushed the boundaries of science and imagination alike. Whether it is a rare, natural comet or something far more extraordinary, the lessons remain the same. The universe is stranger and more complex than we can easily comprehend. Avi Loeb's work shows that embracing uncertainty is not sensationalism, it's science. And whether 3i Atlas proves to be natural or artificial, it has already forced humanity to confront the possibility that the galaxy is far stranger, far richer, and far more mysterious than we ever imagined. In the coming months, as 3i Atlas passes Earth and Jupiter, humanity will finally have the chance to gather data that could explain its anomalies, or deepen the mystery. Every observation, every measurement, every unexpected detail could rewrite our understanding of the cosmos. Regardless of the outcome, 3i Atlas teaches us one vital truth. We must always keep looking up, questioning boldly, and embracing the unknown.